Welcome to our webinar, Chemistry in Transition. I'm Brian Payer, Senior Principal here at RMI. It is my honor to lead the Chemicals Initiative here across the Institute, and we're thrilled that you're here to join us today. I'm honored to be joined by several colleagues to discuss our recently released report, Chemistry in Transition. Today, we will provide some context on the chemical sector, how it's part of our daily lives, and where the greenhouse gas emissions are coming from in the current production processes. We'll highlight some findings from our recent work about how to eliminate or reduce these emissions, and we'll talk about how a constellation of stakeholders can engage to continue our positive momentum and point out where we need to go next. As we begin, a couple of logistical items. First, please do send us your questions using the Q&A function, and we'll compile the Q&A roster and address them at the end of the session today. Second, we will have a few poll questions using the Zoom poll function, so please do respond to those. We value your input. And third, we look forward to keeping the dialogue going. So email us at chemicals@rmi.org. Use that QR code that you see on the screen now. All that information will come to us. It comes to me and the team that you'll see today, and so we look forward to engaging in dialogue with you. Next slide, please. A little bit about RMI. We were founded as Rocky Mountain Institute, and we are a global independent nonprofit focused on accelerating the clean energy transition. We've been at this for more than 40 years, and while we've made tremendous progress, we still have a long way to go. Reducing climate pollution from the chemicals industry is a critical piece of that puzzle, and that will be the topic for our presentation today. Next slide, please. I'm joined by my esteemed colleagues, Ankur, Catherine, and Brianne, to discuss the findings of our report and talk about the chemicals sector. You'll hear from each of these folks today as we go along. We'd also like to hear a little bit about you. So we're going to try our first poll here right off the bat. And if you could please let us know where you're coming from today, which of these best describes your relationship to the chemicals industry. That helps us get a sense of who's attending and who's dealing with this. So while you all are answering that, thank you for plugging in the responses. I will turn it over to Ankur to begin our presentation today. So without further ado, Ankur, over to you.
Thank you, Brian, and hello, everyone. I'll share with you a bit of context on the chemical industry. So chemicals are a bit of a paradox. They are the basis for modern life, but they're also very emissive and have a significant impact on the environment. They underpin 96% of all manufactured goods and are actually critical to the low emissions transition, currently enabling nearly 75% of emissions reduction technologies. So the US industry accounts for about 30% of total greenhouse gas emissions. And of that, industry accounts for 15%. 30%, and of the 30%, chemical industry accounts for 15%. So total, the chemical industry accounts for 4.5% of the greenhouse gas emissions of the US. And in the chemical industry, a small number of primary chemicals are transformed into most of the chemical products that we use every day. You have hydrogen, which is needed for producing methanol and ammonia, methanol, which goes into solvents and paints and coatings, ammonia that is used for fertilizers and nylon, benzene goes into dyes and detergents, propylene is used in a lot of hard plastics, and ethylene in soft plastics. Next slide. The general consensus right now is that chemicals demand will grow considerably even in net zero scenarios. And in fact, in the business as usual scenario, demand for chemicals will at least double, pending ammonia and methanol demand for shipping and as an energy carrier. So what that means is that using chemicals more wisely and making them with a lower emissions footprint will both be necessary to achieve climate goals. Next slide. So reducing emissions from the chemical sector requires tackling a dual challenge. To explain what I mean, I'll use a cooking analogy. So chemistry is like cooking. We source ingredients, process them, and transform them into useful products. But the problem is that the chemical industry relies on fossil fuels, not just for energy, our stoves, but also as raw materials or our ingredients. So to decarbonize, we need new cookware, such as electrified stoves and better ingredients like low carbon feedstocks and fresh recipes like innovative processes. So right now we're frankly cooking with a lot of junk food, producing unnecessary waste. So efficiency and smarter choices about what we make in the first place are just as crucial as rethinking how we made it. Next slide. So emissions are generated at all stages of chemical production, from raw material extraction, processing, and transport, from the chemistry itself, the reactions, and from generating the heat and electricity used in chemical plants. In addition, there are emissions from the use phase of the products of the chemical industry, such as emissions from application of fertilizer and emissions from the incineration of plastics or other waste chemicals. So our solutions for low emissions chemical industry must cover all stages as well. Next slide. The challenge is that the chemical industry is unique in its complexity, thousands of products, a multitude of production methods, and an array of potential interventions. So how we slice through the complexity to quantify solutions that will drive maximum impact across the chemical sector is important. And now I'll pass it to my colleague, Catherine, who's a senior associate on the chemicals team at RMI, to tell you how we tackled the complexity and what we found.
Awesome. Thank you, Ankur. Next slide, please. So for our report and our analysis, we focused on 6 primary chemicals, the 6 that you see highlighted here on the left-hand side of the slide. These chemicals make up 65% of the U.S. chemical sector emissions on a well-to-gate basis. We did not include end of life in this analysis, so very focused on the upstream through primary chemical production gate emissions. Since this report focused on the U.S. chemical sector specifically, our model basically was developed for the key production routes for these 6 chemicals that you see here on the right-hand side of the slide. So we looked at steam methane reforming, syngas production, Haber-Bosch, steam cracking, and then refining for the olefins and aromatics as well. Next slide, please. So how did we develop this model? Using existing peer-reviewed models such as the DOE GREET model, as well as the prelim model, as well as we had over 25 external interviews with industry experts, NGOs, academics, and other think tanks, as well as within RMI, we have over 200 energy and industry specialists. All of those things combined to be able to have us make a chemical-specific model. What this allows us to do is model both traditional chemical production routes for the sector and emissions reduction opportunities. So as we've mentioned, it models the 6 primary chemicals that Ankur introduced on his section, and then it models over 24 emissions reduction levers. What's unique about this model is that we're able to configure it for individual processes. So it's currently, and its default assumption is using mass and energy balances coming from these kind of peer-reviewed open source models. But if there was a desire to modify and use it for an individual site, that is also possible within the tool. As well as being able to be used for an individual site's emissions and understanding of the profile, we can also kind of zoom out and look at the sector as a whole. So the model will provide you a carbon intensity, and then based on production volumes, whether it's for a country or even as we get more global looking, we can estimate basically the sector emissions as a whole. The focus of this report was the US, so all the results that we'll discuss next are US-based results. So next slide, please. So looking at the chemical sector as a whole, you can see this graph on the right shows these 24 plus emissions reduction levers that I mentioned already. Looking at these, you can see there's really no silver bullet for the chemical sector. There's no one solution that can eliminate all the sector's emissions by itself. So our question going into this analysis was, okay, how do we choose which levers that we should pursue? And so what this modeling effort really allowed us to do is compare the different options on an emissions reduction basis, which is what you see here. The values represent the maximum emissions reduction potential if every facility for which the lever was applicable implemented that lever to the fullest extent. And so basically what this shows you is the best case scenario of reductions possible if everything went perfectly. I will acknowledge that this slide is fairly small and there's a lot of data on it. So if you are interested in digging into these numbers, the report that's been linked in the chat, it's Exhibit 16 that shows these same results, in case you're curious. So as we can see on the bar chart on the right, hydrogen from electrolysis is that first bar that has the highest reduction potential for the sector as a whole, as well as process heat decarbonization, high purity carbon capture, and methane leak mitigation close behind. For simplicity for both this and throughout the report, we did lump these levers into different categories, which are the 4 colors that you see here. The first category, going back to Anker's cooking analogy, is alternative production methods. So how can we make these chemicals differently? This would be similar to, how can we bake a cake without using an oven? We've heard of maybe using even a rice cooker that's less energy intensive to achieve that same final product, which is a cake, or in our case, chemicals. Alternative energy and heat, we're looking at how can we provide heat input from maybe a cleaner or renewable source. This would be the example of switching your gas stove to an electric stove, ideally powered by renewables. Cleaner operations is the third category. How can we use existing methods, but maybe have them be cleaner or have less environmental impact? This would be things like certified low leak natural gas, which is available today, as well as potentially in this cooking analogy still an extractor fan in the kitchen. You're cooking and hopefully reducing the emissions that are in the space, but probably still cooking the same way. And then finally, alternative feedstocks. How can we make chemicals without using the high emissive fossil feedstocks? This would be analogous to making a gluten-free cake without flour. So of these categories, if we lump them together rather than looking at the 24 emissions reduction levers, the ones that we have determined have the highest potential are alternative production methods, so making something a different way than we do today, as well as cleaner operations, so cleaning up the way we make processes today. Next slide, please. So as I mentioned, this can be used for both the chemical sector as a whole, which is what we saw on the previous slide, but also can be looked at from an individual facility basis. So since we modeled steam cracking, I'm going to just show you this example. In the report, we also look at refining and we look at hydrogen-based molecules as well. So for example, this steam cracking facility has multiple emissions reduction levers that apply to steam cracking, and specifically you could source ethylene from an ethanol dehydration facility instead of from a steam cracker, which if you know about steam crackers, they are highly energy intensive. They operate at very high temperatures and therefore require a lot of fuel. We could also reduce process heat or decarbonize process heat, which is a strong option for these highly energy intensive processes, as well as you can see on this graph, alternative feedstocks. So based on this modeling that we did, we determined that for steam crackers, decarbonizing process heat is the most impactful lever. This has options like clean hydrogen to replace the fuel that is currently used, which is typically natural gas, electrification of the steam cracker itself, which is being pursued in industry, as well as blue hydrogen firing. So blue hydrogen firing, slightly less emissions reduction potential as compared to a fully clean hydrogen, but still provides pretty significant emissions reduction. One thing I'd like to highlight on this also is that it shows the importance of prioritizing upstream methane leak mitigation. We see a potential of 26% emissions reduction by taking the leaks in the upstream methane that's coming into these sites from the US average of 2.2% leakage to the certified standard of 0.2%. What this does is, this is especially important for US steam crackers because the leaks and the leak mitigation technologies that we are seeing deploying are, one, readily available today, and two, they impact not only the fuel going to these steam crackers, but also the feedstocks, since they are typically natural gas liquids. So this is just an example that I wanted to show out there of how this model can be used. It can be modified for the production of each of the 6 chemicals that we discussed and kind of their various emissions reduction levers that apply to those chemicals. Next slide, please. So everything we looked at so far was, as I mentioned earlier, kind of a idealistic, if everything went to plan and all these sites implemented their solutions that they could, how much reduction could we get? But we understand that this isn't always possible everywhere, and not all of these levers can be deployed today. And so what we have done is looked at a deployability analysis is what we've called it. So we determined the top 10 levers, which you can see on the screen here, that are deployable today based on their technology readiness level and current commercial scale. And we were able to perform, based on this map that you see on the right, a site-by-site analysis based on geographies, policy landscape in the specific locations for all of the production sites in the US. We looked at things such as proximity to CO2 storage and pipelines, availability of recycled feedstocks, and then other indicators that could really influence the adoption rate of these various deployable today solutions. In addition to just looking at what exists today, part of the analysis focused on what are 4 policy and infrastructure improvements that we could implement that would potentially increase the uptake of these deployable today levers. These would be things such as increasing, if the 45Q credit were able to be increased by $10 a ton, if we had further regulation on methane leak mitigation, if we had more recycling, so more end producer responsibility and bottle bill regulations, as well as additional incentives that we could deploy to bring down the cost of blue hydrogen. So once we did this deployability analysis, what were the results? I will show you on next slide, please. So the graph on the left here shows that the first layer, so just deployable today based on geography and kind of policy landscape, we determined that 34% of chemical sector emissions can be mitigated by these 10 deployable today solutions. The additional 4 policy and infrastructure improvements that I'd said could lead to an additional 14% reduction, which is great, but does leave 52% of emissions remaining to be mitigated. And so we believe that we need to do 2 things in parallel for the chemical sector. One is accelerate these current solutions, as I discussed on the previous slides, and then 2 is double down on innovation. So what can we innovate on to address those remaining 52% of emissions? Next slide, please. So on the innovation side of things, there are kind of 3 key focus areas. Step 1 is make less. So recycling, circularity improvements, reuse, as well as design solutions to maybe use less chemicals in the products that we use today. We really see this as the first step, since it reduces the amount of feedstock and product required to achieve the same functionality that we have today. So we'll just make potentially less chemicals to the same functionality. 2, make better. So how can we make the same products using less energy than we do today? Things like efficiency projects within production facilities, as well as direct electrification, both result in less energy use compared to the traditional methods that we use today. Innovators in this space, I would say, are looking to make the same products as we use today, but through more efficient and less energy intensive processes. And then finally, make new. So how do we make the same products using different feedstocks or even production methods and even different business models as we look at modularity solutions and more dispersed operations? So innovators here are really looking at how can we just disrupt and make either the same product a completely different way, or make different products that can achieve the same functionality for society. So we can launch the second poll today, which is, we're just curious to see, where do you see yourself and your organization fitting into this space? So just trying to get a pulse of who's here today and if we're really what we're thinking about in this innovation space. I'm going to give it about 20 seconds to take a look at these results, and then we'll get a sense. All right, based on the initial results, it seems like we have a lot of focus in the make better and make new, which is super exciting. I love to see all this innovation that's coming into the chemical space. I think in a sector that's has very traditional production routes, it's really exciting for these new innovative technologies to come out. So thank you. I think we can end the poll. All right, I think the main takeaway that I want to share with you all today is, although we have a lot of people in the make better and make new spaces, I think it's really important that all three of these areas in innovation are focused on. We really need all of this for the chemical sector to make progress towards reducing that final 52% of emissions. All right, so I will now pass it on to Brianne, who is a manager in our chemicals team, to explain, now that we have these results, how do we make them happen in real life?
Thanks so much, Catherine. Yes, so what needs to happen next? We believe that we need to continue to build the field with data through emissions visibility and shared goals across the diverse stakeholders in this ecosystem while advancing the two parallel paths that Catherine alluded to. As our team likes to say, you can't manage what you don't measure. And we must improve our understanding of emissions from the sector and emission reduction levers across the globe, including key regions like China and India beyond our US analysis. We also recognize that the sector is complex and nuanced, as Ankur showed on that Sankey diagram earlier, and there are many folks that have been working on portions of the problem for years, including the issue of plastic waste and circularity and others. And we would benefit greatly from increased coordination across these efforts. Additionally, we first need to accelerate current solutions to cleaner production through deployment of existing technology, the 10 that Catherine mentioned, accelerated efforts for coordinated infrastructure deployment, national and subnational policy interventions, and harmonization of standards and accounting procedures to enable transactions of lower emissions products. And second, we need to double down on innovation through increased spending on research and development, partnerships and pilots to support new technologies in coming down the cost curve, and evaluating the opportunity posed by more modular solutions that in many cases require lower capital commitments and can benefit from co-location with feedstocks and offtake. Next slide, please. As I mentioned, we recognize that this will require coordinated effort across a number of stakeholder groups, a few of which you see on the slide here. I'm going to build on Catherine's earlier discussion of a steam cracker, where one of the many opportunities we have is to reduce emissions through process heat decarbonization to make low emissions plastics, like a plastic bottle. When you think about what it takes to do that, NGOs are needed to raise ambition for near-term action. Policymakers can develop incentive structures or support infrastructure that enables the business case, and retailers can drive demand signals for low emissions product. At the center are the chemical producers of today and tomorrow that pilot these new technologies and bring them to scale. All of this is underpinned by the need to engage local communities and consumers to ensure meaningful involvement in project development and a clear understanding of the health and environmental impacts of the end product. Next slide, please. So we're really glad to have had the chance to scratch the surface of our analysis and report with you all today. We hope it's piqued your interest and left you with new ideas or questions that you'd like to pursue further. But this is actually just one portion of the work our team does here at RMI, and you can see a few other ways to engage with us on the slide here. These include net zero strategy, so evaluating emissions reduction pathways at a sector level, like we've discussed today, but also to plant and project level assessments. These are really built on our foundational emissions visibility work and modeling, and we hope to extend that in the near term to China, India, and other geographies. RMI also has a foundation in market-based mechanisms, including demand aggregation platforms to spark offtake for emissions differentiated commodity products. And we're working to build out this effort for select chemicals. And innovation, we have collaborated closely with Third Derivative, which is RMI's climate tech accelerator, to launch a chemicals-focused startup cohort, supporting early-stage innovators in bringing solutions to market and also launched Mark 1, which is our DevCo as a service collaboration with Deep Science Ventures to support first of a kind project development. And lastly, we'll be releasing an applied innovation roadmap later this year to provide an independent perspective on how to accelerate deployment of electrification technologies for the sector. We believe and feel that momentum is building in chemicals, and now is the time to scale impact if we want to see meaningful progress on 2030 goals. So please don't hesitate to reach out with any questions or ideas on potential collaboration. And with that, I will turn it back over to you, Brian.
Wonderful. Thank you to Brianne and Catherine and Anker for walking us through the report and teeing things up very nicely. And thank you to each of you for joining us here today. We have one more poll, which we'll ask you to participate in, and then we'll move into our Q&A section. So with this poll, as Brianne mentioned and outlined, it takes a village, and there's plenty of ways to engage. So if you would like to join us, please let us know and click yes so that we can follow up with you. Whether that's a specific question about a project or an idea, or feedback about what we're getting right or what we're getting wrong or what we're missing, or something we may not see, or you just generally want to join us on the journey, please click yes, and we'll follow up with you. For more information on the full breadth of RMI's work on chemicals, you can please check out our landing page and see a variety of the articles and the work that we've published that touch on several of these topics, everything from innovation to demand management to the role of hydrogen to the role of thermal batteries and everything else in between. If any of these things generate ideas or questions, or you see things differently, perhaps especially if you see things differently, we look forward to hearing from you and discussing further. Now let's move into the Q&A. Thank you to the many folks that have already put questions into the Q&A. We have several and would encourage you to use that Q&A function to put the questions in here. So I'll be moderating this, and we'll have all of our presenters available to respond to the various questions. So first up on the Q&A roster is this one's going to be for Catherine, and a couple questions that are similar here. How is this report unique from other chemical sector reports that are out there? Catherine.
Yeah, thank you, Brian. I think many of the reports that we see in the chemical sector that are looking at the chemical sector are really providing a holistic perspective on what long-term trends could look like for the sector based on, educated assumptions about what may happen going forward for chemicals and policy. These have really helped us and can continue, and I'm sure will continue to help us kind of provide a North Star for the ambition of the sector and like where it could go, where should we go? I think what this report is additive to that is really this ability to analyze individual sites and their emissions reduction levers, so that whether it's corporations, whether it's policymakers, or really anyone involved in the climate space, we can make more of a data-backed decision on which of these, 24 levers that I mentioned, and there may even be more that we want to include at a later date as more innovation and more solutions come out. Which of these levers should we be prioritizing to accelerate, invest in, make policies for? And so our goal here has really been like, how can we get the sector talking about these solutions and really understanding how much of an impact could the different ones have, and maybe what are the challenges that we need to overcome to make these solutions more impactful.
Thanks, Catherine. I'm gonna stick with you for a second one here. Is the a couple of the bio-based feedstocks and solutions actually showed up as negative. Can you explain what's going on there and what's driving that?
Absolutely. Yeah, I know this was surprising to us as well as we looked at them. So I'm glad someone asked the question. For the biological feedstocks in our modeling efforts, we are using literature values for their collection and processing, as well as most of these emissions and literature values are pulled from GREET. and used credits basically based on incineration, etc. And for this analysis, what we did is we actually avoided using any credits for either avoided emissions or incinerations. And so we totally acknowledge that there are potentially better land use change or better processing ways to get these feedstocks into these chemical production facilities. And our feel was that those are very site specific and feedstock specific. And so we kind of went with the conservative approach in our analysis, but we are able to, with the kind of customized modeling, we're able to look at those different feedstocks. If you have a specific one that you get that you know is a certain carbon intensity feedstock, we're able to sub that into the model, and it might yield a slightly different result than the kind of the generalized view that we showed in our report. So, yeah.
Thank you, Catherine. Perhaps unsurprisingly, we're getting a couple questions about policy. And Brianne, I'm going to tag you in for this one. Just starting with an overarching question. Given the political climate, what actions outside of policy do you see driving implementation?
Thanks, Brian. Yeah, I know this is top of mind for a lot of us right now. I think a couple of things. There are cost-effective actions that can be done today. That was a huge, headline takeaway from the modeling work that we did, especially around procuring low leakage methane as a fuel and feedstock for the sector. Has really big emissions impacts and, is pretty straightforward to do and doesn't require a large CapEx spend. So we see that as a huge opportunity. We also see voluntary demand generating in consumer-facing value chains like polyester. And as I mentioned earlier, we think there's an opportunity to prove out markets for low emissions chemicals through demand aggregation and approaches like buyers' alliances, where RMI really has a robust history with successfully developing and implementing to create markets for low emissions products. This has been the Sustainable Aviation Buyers Alliance for jet fuel. We have the Sustainable Steel Buyers Platform and ongoing efforts in the cement space. And if we can aggregate demand and work through the nuances of actually how to tactically transact on a lower emissions product, we believe we can incentivize emissions reduction projects by showing that there is a willingness to pay and establishing guaranteed offtake to enable financing. And lastly, I don't want us to completely write off policy. We are actually seeing highly ambitious states remain pretty curious about near-term action that can be taken to enable emissions reduction projects, especially around electrification of low and medium industrial heat.
Thank you, Brianne. Appreciate that response. There was actually a couple questions about heat, and as we noted in the report, and the heating processes, low, medium, and high temperature heat is one of the largest sources of emissions. So Ankur, I'm going to tag you in here. Can you comment on the status of deployment of industrial heat technologies that are low emitting? And I know you've worked quite extensively on several projects and studies in this. So what are you excited about? And also, what are some of the barriers that you're seeing?
Yeah, thank you, Brian. Industrial heat, I feel like, is kind of maybe the low-hanging fruit for the chemical industry. And when we talk about heat, we need to talk about efficiency first. We have significant waste heat losses from poor system design, leaky steam systems, and poor automation and control of fossil-fired boilers, furnaces, and other heaters. And solutions to these problems typically have payback periods less than 2 years, and maybe 2 to 3 years. But they struggle to get funding at chemical companies because top-line growth projects and safety projects are prioritized. So there's a nudge needed to kind of help the industry implement these no-brainer from a business standpoint projects. And I would say the next step is we need to electrify, especially starting with things that are at the intersection of electrification and energy efficiency. And this would include things like industrial heat pumps, These are kind of a win-win-win. You reduce emissions, you cut variable costs, and you improve energy efficiency. And they've been proven in the food and beverage industry and are ripe for adoption in the chemical industry. So I would actually say any new build should, by design, incorporate heat pumps, and existing sites should be evaluating their benefits, because you may not need anything other than just looking at the technology and seriously considering it to say, yeah, this is the right decision. We should be implementing this. It makes business sense. And then we have things on the horizon like thermal batteries. They can serve as drop-in replacements for gas-fired boilers and other equipment. But the challenge right now is that they struggle on operating costs when compared to a gas-fired boiler because of the cost of electricity being much higher. So again, regulation can help level the playing field there. But I'm excited about process heat in general. I think there's a lot of scope to improve efficiency and start electrifying things. And I'm excited about the actions that states can take to incentivize some of the small things with funding that's already available to accelerate progress in this direction.
Great. Thanks, Ankur. Don't go far. I'm going to come back to you in a second. I'm going to address one question quickly that was pointed out, that a questioning about other pollutants, toxics, NOx, VOC, particulate matter, et cetera. And yes, our report is greenhouse gas and climate pollution focused. That is the lens that we took in our report. Absolutely, we recognize the role of other emissions, other air emissions, water emissions, and other pollution sources from the chemicals industry. That absolutely has to be a part of the solution as well. And we know that likely many of you attending today are working on those aspects as well. Our report is focused on GHGs, not necessarily to the exclusion or to ignore those other impacts or pollutants. The goal of our work here is really to look at the industrial decarbonization aspects, and we absolutely look forward to partnering with others and continuing to look at overall toxics reductions, health benefits, and pollution reduction from the future chemical industry across all pollutants, climate, health, or otherwise. Ankur, I'm going to come back to you on this one. There was a question about what role do you see the general public playing in the transition of the chemical sector?
Yeah, thanks, Brian. Yeah, we mentioned at the start of the presentation that chemicals underpin 96% of all manufactured goods. And as the consumers of these goods, changing our consumption patterns is probably the best place where we can make an impact. This would include consumption of things like plastics and clothing, just being more thoughtful in our use, and where it's available and affordable, maybe substituting with products that have a lower environmental impact. And then second, I would say it's just realizing that there are important proceedings happening at the state and local level where you live that decide the direction and the future of industry. And these proceedings need your engagement. They need your voice to be heard. So educate yourself on what's going on and engage with it.
Wonderful. Thanks, Ankur. I'm going to stick on kind of this theme of educating about the chemical industry and bringing this to the forefront, because I think that really is one of our what we see as part of our key mission here at the chemicals team, is to really put chemicals on the map, and let's have a robust dialogue about the solutions to reducing climate pollution. And Brianne, I'm going to try to tag you in here a little bit and maybe say a little bit more about how RMI envisions continuing to engage and educate others and engage in dialogue around the chemicals industry.
Yeah, absolutely, Brian. I think three main ways we are doing this already and hope to continue to do this come to mind. So we put a lot of work into the past year over developing that landing page that I dropped into the chat. And we have a lot of kind of foundational articles, kind of 101 blogs that help frame, what is this sector? Why is it important? What's its climate impact? And what is the view of how it will still be needed going forward. So I would definitely take a look there for resources to help educate yourself or others that you work with. Second, RMI is actively collaborating and convening with other NGOs in the sector that may be thinking intently about other parts of heavy industry and getting curious about chemicals, or many who have been working in the space for approaching it from different angles. Toxicity is obviously a big concern with the sector, waste, as I mentioned earlier, and others. So if you are an NGO, an academic, a think tank wanting to engage in that conversation, please reach out. We welcome you. And we are also working, in our relationships with partners and funders, and just the ecosystem at whole to really leverage these resources as we can to help them understand why this area needs funding and thought and a lot of intentional activity as we head towards 2030. So if there's ways that we can be supportive in helping those education efforts, if you fall into that category, let us know. That's something we're actively doing.
Thanks, Brianne. Appreciate that. And look, the team here has heard me say this, but we believe one of our most critical roles is to amplify the art of the possible and put a big spotlight on the projects and the companies and the stakeholders that are really making progress and helping us chart that course forward. So this is really why it does take a village. We need to be hearing about the solutions that are reducing pollution of all types, that are managing the overall demand, that are using the chemicals and materials that we can produce more sustainably, that require fewer inputs, less energy, less material waste, and that's really what we're all driving towards. And it can be devilishly complex, but we've got to start and keep chipping away. So excited to keep working on those. Also, just for perspective here, I'm going to ask each of the panelists, can you raise your hand if you worked in an actual physical operating chemical plant yourself as an engineer, technician, or otherwise? Yes, go ahead. So I think it's, that perspective is really important in what we bring to the work, that it can seem easy from the outside to just kind of wave your hand and say, well, we're just going to change this process. And it's like, well, that process has been highly engineered to start with. There are safety protocols, operational protocols, and a business to run. So we certainly respect that it is challenging, and there's a lot of competing interests and competing objectives to go forward. So we're working hard to make the business case for these lower emissions, lower pollution alternatives. Looking at the Q&A roster, it's slowing down just a bit, so thank you for those. We're probably going to maybe get one or two more in here before we close out. So I guess I want to do one more question, a little bit about demand and some of the questions about actually creating markets for lower emissions products. And Catherine, I'm going to toss this one your way. You mentioned demand. You've also said there's thousands of chemicals and products. What products has the RMI team looked into, and what are we learning from some of those analyses?
Yeah, thanks for the question, Brian. So a lot of this report that you've seen is very focused on the supply side of chemicals and how do we impact the production phase. But to Brian's point, we are also talking about demand and how do we get enough demand such that people are willing to invest in these technologies that we've kind of talked about today. So what we have done as a chemicals team here, we've looked into kind of different supply chains and what is the demand that is there for low emissions products and what kind of impact could that have on the chemical sector. We've started with polyester because there is, if you've looked, there's a lot of demand for whether it's recycled polyester or low emissions polyester out there. People are looking to potentially brands that are willing to, pay a premium to have a lower emissions product. And so polyester is where we started. What's good with polyester is that it comes from both, its primary chemicals are ethylene and benzene. And so two of the chemicals that we have studied kind of extensively as part of this analysis. But the struggle that we found is that there's a disconnect between this demand for recycled content, low emissions products, and the upstream chemical producers, because there's so many steps, to your point, Brian, of thousands of chemicals. There's a lot of steps in between those two things, from a store that sells a shirt to a chemical plant producing ethylene. And so what we're really trying to understand is, how do we link those two together better? And what we've learned so far is that we have this downstream demand for low emissions, maybe t-shirts or clothing, but we really need to start activating demand for low emissions primary chemicals themselves. Without doing that, we won't be able to actually impact the chemical manufacturing part. We might impact some of the downstream operations that are potentially electrified or able to be powered by renewables, but we won't have the impact on these big investment decisions that are required for the chemical companies. And so if we are able to differentiate these upstream primary chemicals, that's where we really start to aggregate enough demand and maybe be able to actually get confidence that these chemical producers will have willingness to pay and will be able to invest in these pretty expensive solutions. So, like I said, started with polyester, we're progressing into primary chemicals, and our next step is really, how do we activate and demand for the primary chemicals themselves.
Yeah, thanks, Catherine. I appreciate that. This is, I have to admit, this is some of the work that I am the most excited about, as we've really started to unpack the demand levers and really start to understand the role of incentives and where they're actually going to reduce emissions, to see where we can get the most impact and what's practicable. So it's been really great to engage with dozens of producers in the polyester value chain at many stages, and we look forward to doing a lot more of that going ahead and finding some solutions. So I will take a couple quick ones here and then wrap towards a final question. There's a couple pretty detailed questions that have come through on the Q&A. We'll try to follow up with those individually, offline or separately here. One more that I do want to take was talking a bit. Can you talk a bit more about the scale of the facilities and how startups or smaller scale can be exceptionally challenging to create cost competitiveness? Yes, yes, we can. And earlier, Brianne alluded to the innovation ecosystem that we are working to foster at multiple stages. So first, upstream R&D with the Advanced Innovation Roadmap, marshaling resources, both financial and brain power, towards the key questions to make things new, make things differently. We have our third derivative program, which is RMI's Climate Tech Accelerator, and we've recently launched our chemicals cohort, and we'll be announcing the companies that are part of that cohort to help from that early stage that are scaling. So this is, out of the lab and getting those into decent sized deployment. And then really we felt this gap, and we're hearing from a lot of stakeholders, not only in the chemicals industry, but also in steel, in cement, in hydrogen, in related heavy industries. How do you actually get something over the hump from, I can make, tens of pounds of this, to I can make hundreds of pounds of this, to I actually need to serve a market where I can get reasonable percentage at, millions of tons per year. That's why we've partnered with Deep Science Ventures to launch our Mark I program to help more companies over that first commercial scale valley of death. Look, it's not easy. It's really challenging, and it takes folks that understand project finance. It takes folks that understand offtake agreements and longer term markets, and it also just takes some support from a variety of partners, engineering, procurement, construction firms. So that's what we've tried to marshal around that ecosystem at multiple stages. So we've got third derivative for the early stage to prove it up, and we've got Mark 1 to take those promising scaling ideas and get them over the hump to get them in the market. One other thing that I will plug as an interest and would love further dialogue on this is, what is the role of modularity in the future chemical industry? If we imagine what the chemical industry could look like in 5, 10, 25 years, will it still be centralized world scale plants? To some degree, probably yes, but how will there be a role for smaller regionalized types of production that are closer to, say, more circular feedstocks or closer to certain end use demand? I think it's really intriguing. We've seen some early signs of that in multiple ways, but we'd be happy to help companies along the journey to prove out those areas. All right. Last question, and we'll tag in each of our esteemed panelists here today. Maybe Ankur, then Catherine, and Brianne, you get to bring us home. What was the most surprising result that you found out of our work so far, whether this report or our work broadly? And Ankur.
Yeah, Brian, thank you. I would say maybe not the most surprising, but for me, the most relevant thing has been the realization that the biggest challenge is in industrial and chemical sector decarbonization is cost. Many solutions today are too expensive, and even the cost-effective ones aren't being implemented, adopted at the scale that we need them to. And kind of like I mentioned on the question about process heat, in near term, we need to focus our efforts on efficiency and electrification, especially when it gives you an efficiency benefit. Modernize facilities with improved controls and automation and heat integration, because those are easy wins and they make more business sense than the emerging technologies. And industry already has expertise in implementing these, so I feel like giving a nudge there would be really nice. What I'm excited about working on next is addressing kind of what you talked about, Brian, is getting projects over the hurdle. Like, we have a reasonable understanding of what can be done to reduce emissions, but we need to work on the how. And I'm excited to develop facility level and state level roadmaps to tackle real challenges, from deep decarbonization of assessments of facilities to conducting early stage engineering and analysis to kind of help make the business case for projects and get more projects through the pipeline at these companies, and maybe even innovative financing models to kind of get things like process heat over the hump with things like energy or heat as a service. So yeah, there's so much to be excited about.
Great, I'll go next. I think one of the surprising things for me doing this deployability analysis that I talked about was really the regionality of which solutions work and where. I think sometimes we lump the US into one big, I mean, it is one big country, but into one big solution, and that doesn't always work the same in different places. We have such variance of where's their CO2 storage potential, where is their good renewables, and those things are just so regional. And we have chemical production facilities kind of in some concentrated locations, like along the US Gulf Coast, but there's also a lot of these production facilities that are all over the US. And so it was really fascinating to look at what solutions work for which chemical production pathway and where, or could work, I guess, for which chemical production pathway and where, and really get a better sense of that it's not just one size fits all solution, but there are solutions that work everywhere, which is exciting. I think what I'm excited to work on is this demand side piece that we talked about pretty extensively today. Is just a lot of these solutions won't happen unless they make financial sense. And so how do we get the demand that people are asking for to back up far enough along the supply chain to the producers that are wanting to invest in a solution? And so really interested in how do we actually push it back up and get, pipes in the ground and really get these projects out there and working.
I think I'm last. I'll jump in. This is a hard question for our team, as you can probably tell. We're passionate about a lot of different avenues of our work. Things that I found particularly interesting, and I know we've already discussed it today, and I think we came in with the hypothesis that there was no silver bullet for the chemical sector, but I think it was really insightful to see how many things are at scale today that could reduce sector emissions by almost half. And we need to get to work on large scale deployment. And second, I can't pick just one, it's that the remainder will be needed to need to be mitigated by things that don't exist yet today at scale. And given the pace and size of the problem, it means we need to get to work now. Which leads to, I think, one of the many things I'm excited about. We've spoken about it a bit already, but these startups that we're welcoming into our accelerator with their derivative and really rolling up our sleeves to support them as they develop their technology, their business model, and connect with partners across the ecosystem. We recognize the importance of these partnerships and potentially even pilots with industry incumbents is kind of a key step to scale. And I'm excited to see how we can support that over the next 18 months. And this work has been incredibly insightful in demystifying a sector that I think just gets a reputation for being overly complex. I think to one of the questions I answered earlier. And I'm excited to get to extend this work to create a global view of sector emissions and potential of emissions reduction levers to reach a net zero future. So back over to you, Brian.
Thank you, Brianne, Catherine, Ankur. Really, it's a great joy to work with you all, and kudos to the extended RMI Chemicals team and collaborators. Very grateful for this as a team effort. Thank you all, attendees, for joining us today. Thank you for the rich dialogue. Thank you for the questions, the comments. Please do stay in touch. There are several items noted here that we'll follow up with. Reach out at any time, chemicals@rmi.org. We look forward to hearing from you. And if you think that there's someone else that needs to hear about this work or talk to us, please do share. We look forward to the ongoing discussion and dialogue. With that, we'll close our webinar for today. Thank you very much.